Hi everyone. Um, so um, so this is the visibility problem, which I've explained in class and was used to introduce or motivate the idea of parallel prefix sum. And a few of you were asking me even during the earlier Zoom review session for a solution. So I'm just presenting it here because I've been getting a few emails regarding that problem, and it was also a problem in the previous midterm. So I hope that this explanation is a crisper one that you'll understand much better. Now, one a problem that I've seen in many students when they try to understand the solution to this problem is that when I ask them if there is, if now let's say that you are situated here, all right, this is where you are, this is your I, and I is denoted by E. So if you want to check if a particular point Y or X is visible, you cannot use their heights to determine if a point is visible or not. So for example, if, as you can see here, X is clearly at a lower height than Y, but clearly Y cannot be seen by X, right? If you notice what I have drawn this dashed line, which basically basically indicates that nothing to the right of that dashed line after this big vertical pillar X can be seen. All right. So nothing can be seen basically in this region. All right. And that, of course, includes Y. Right. So this line of visibility is really important. So I have just summarized that principle here. Even though Y is higher than X, E cannot see Y because the line of vision is blocked. The line of vision from E to Y is blocked by that pillar X, and obviously you cannot see. Okay, so remember, it's the angle of elevation that matters. Now, given a particular pillar, whose apex I'm denoting by the letter, just like it in the previous class, let's call it X. Then its angle of elevation, theta X, can easily be determined by taking the tangent of by computing the tangent of the angle, by taking the rise upon the run, as they say. All right. So for instance, tan theta is equal to hx upon dx. And then the angle of elevation can be computed as the arctangent of hx upon dx. Remember, it is assumed that hx and dx are given to you for each pillar that's visible to you in the problem, right? It's, after all, it's a map that's given to you. So it's assumed that all geographical distances, any distance information that you need to know is available there. We are assuming that the Atlas designers have done a fairly good job, right? And I want to emphasize that the main idea is it's the angle of elevation of a point, not the height of the tower, that's going to determine the visibility. Okay, so here is a very simple scenario. Here are four pillars. Now remember, since we are appealing to parallel computing, and this is what the distributed computing course is all about, it's all about teamwork. You should, in principle, instead of four, you should instead assume 4 billion or 4 trillion or something like that, right? Because that's really large data. So, but we just want to see how we can do this just for four pillars. We are using parallel prefix sum, remember, because parallel prefix sum is extremely easy to implement. Um, well, I mean, it's a very fast operation that can be done by a large number of threads, and that's why many algorithms use parallel prefix sum in their implementation. It's probably the most used fundamental primitive along with reduction. All right, and that's why I've been emphasizing that so much in our classes. Okay, so philosophy apart, we can assume that given four pillars and our position in the map here, the angles of elevation can be computed very easily. So for instance, I have computed here in an array theta A, theta B, theta C, and theta D. Now, remember that a particular point, the top of a pillar, can only be seen if its angle of elevation is greater than the angle of elevation of all the previous pillars. So for example, if you see B, B can be seen from E because its angle of elevation is greater than that of A. All right, we'll see this in just a moment. I'll draw some lines so that you can see it. Now, the main idea behind this is you compute the max pre-scan of the array. Now, remember, maximum is an associative operator, right? And so it's easy to compute its prefix sum with respect to an array, right? And specifically the pre-scan. So we start off with 0, all right? And we compute the pre-scan of this vector as 0, theta A, maximum of theta A, theta B, maximum of theta A, theta B, and theta C. Okay. And now in this array called visible, we are going to record with true or false, or if you prefer 0 or 1, whatever, and decide whether that particular point is visible from E or not. Okay, and how are we going to do this? We are going to do this by element-wise comparison. We have two arrays at our disposal here. The first array is the angles of elevation, and the second array is the max pre-scan of those same angles which were computed before. What we are going to do now is basically compare them element by element. And remember, this is a trivial parallel operation. You can just use the hashtag pragma OMP parallel for to do this, right? I mean, it's just you're doing independent pieces of work, right? So you can launch threads to do that independently. This isn't really rocket science to understand. Okay, so what do? We now just compare theta A with 0, right? Is theta A greater than 0? Yes, it is. Duh, right? It's there. I mean, the theta A can be seen by A. It's the first pillar. And that's why I'm going to mark whether this is visible or not with a T. T for true. I might as well write, well, I'll write true. Okay. So that means A is visible from T. Now let's do the comparison for B. Is theta B greater than theta A or not? Well, for that, we have to basically check the angle of elevation of theta B. Well, remember, theta B and theta A are numbers already computed, but we just want to visually see that the angle of elevation theta B is greater than that of the angle of elevation theta A. So if you, of course, this is stretching my artistic ability, so you'll excuse my drawing here, but you see theta B, that's my theta B, is greater than, let me change my colors, is greater than theta A, right? The yellow line rises above the green line. And that's why I can use this and say that, hey, this is true. That is, B, I'm saying this is true because B can be seen from the point E. Now let's do this with this particular element, C. Okay, what do we have to do? We have to check whether the angle of elevation of C, right? What's the angle of elevation of C? Let's use another color to draw this. Let's use orange. All right. The angle of elevation of C, which I will denote as theta C, we want to check if it's greater than the maximum of theta A or theta B. Now, the maximum of theta A or theta B is clearly theta B, and obviously you can see the yellow line is way above the angle of the yellow line is way greater than that of the orange line. And that's why I will mark this as false. By marking this as false, I am saying that C cannot be seen from E. Okay, and now finally, in order to decide for D, we have to check whether D can be seen from E or not. Now let's see. How do we do this? Let's use another color for D, and let me choose this color, whatever. So now, if I draw a line from here to D, and I hope this line will connect. Okay, I think that's good enough. Then clearly, let's this is theta d, right? Now clearly this purple line or light purple line, the theta d is greater than the maximum of theta a, theta b, and theta c. The maximum of theta a, theta b, and theta c is theta b. That corresponds to that yellow line that I have drawn there. And theta d is greater than that. And that basically means that indeed E can see D. Now, if there were a larger number of points, you would basically perform the same operation, right? There's nothing to do here. Now, and remember, this can be computed, this sequence of numbers can be computed very efficiently using a parallel prefix sum. All right? You can find more information about this in the slides. So yeah, that's it. As you can see, it's a very easy problem and a very beautiful one that's used to introduce the concept of parallel prefix sums and its importance in various kinds of computations. Hopefully that cleared everything up. Thank you.